In today's screencast, we'll be covering Python lambdas, what they're used for, and when you want to use them. And of course, cover a few examples. Oftentimes from new Python developers, I often hear, what's the point of Python lambdas? Generally, for the most part, I rarely use them, but there are some cases when you should use them, so we'll highlight a few examples there. We'll also go about understanding what they actually mean and how they actually behave to give you a better understanding how to use them when tackling trickier problems. In order to understand how lambdas work, we first need to revise our understanding of why we write functions and how we write them. Now, in Python, there are two ways to create functions. One is with def, and the other is with lambda, which we'll be covering today. Now, the difference between the two of these is that with def, we have to give the function a name. So, for example, we're going to give this function the name of power, and we're going to give it a few arguments, x and y, and we're going to have it do something later on. Now, a reason we'd have a function like power is to encapsulate some work that needs to happen together, so we can easily use the power function whenever we need and reuse it. So it allows us to group more complex statements into a particular function that we give a certain number of arguments to, which then gives us a result. Now with lambdas, it is the same thing, but they don't have names. They are anonymous functions. So for example, if we wanted to get the desired same exact result as the function above, we would have something like this as a lambda. It takes two arguments and it passes. Now we're going to implement each one of these, and I'm going to show you the difference between each one of those. So for example, if we were to we're going to implement the powers. So we're going to import math. We're then going to rewrite this. So we're going to go math.pow x comma y, and then it's going to return this value. And then for here, we're going to have math.pow x comma y, or not 6y, and then we're going to assign this to power so I'm able to call it. So we're going to go power is equal to that, and we're going to go if main, we're going to print power 2 and 2, and we're going to go power 1 2 and 2. So in our understanding, this should print 4 and 4 if we have our math right and our functions right. So as you can see, it printed 4 and 4. As you can see here, we simply passed an expression to the right side of the colon here. We assign that to power. We passed the arguments to power, which then became x and y, and then it was called math.pow. That result was returned, and that was printed. And I don't need to cover how the function works. We passed the variables in, we called it, returned the value. Now, the interesting thing between these two things is that we have a name for power up here. So if we were to go, just before we return these, we're to get rid of this assignment here. We're to print the lambda, and we were to print power. What we would see would be quite interesting. And this is where the power, or some of the power, comes in play. So we're going to save that, we're going to run. So as you can see here, the function power has a name. It has been assigned, it has a name, it is useful. Now for the lambda function, it has no name. It comes up as a lambda, but it is a function nonetheless. So that's where the lambdas get the name for being known as anonymous functions. They're anonymous in the fact that they don't have a name, and they can be passed around as functions without much thought into them. And that's where they become useful. Another useful thing for lambda functions is to encapsulate one expression into a function quickly while maintaining readability. So for example, let's rename our power function to a button. This button takes x and a y and a function, and it calls that function, so it returns that function. Returns that function with x and y. Okay, and then we're gonna call that function like we do here with our lambda. We're gonna get rid of that. We're gonna call button here. Now our button requires a function. That function is gonna be provided with the lambda. So we can pass this as an argument to our function, which we will then call that against, and then we will print the result. Complaining about the new line. We'll then call our function. This should produce a 4. So the interesting thing here you should note is that this lambda allows you to pass one expression to a function to allow it to call it. So for example, we could implement the same thing like this. We can call it power, and we would do x and y, and we would do return math.pow x and y, and then we could simply assign this power here, and the same result would happen. But now this makes us have to bob around and look to see what power is and come back and do that. What the lambda allowed us to do was to simply define the expression, the singular expression here, pass that to our function, and have our function call that back. So this is kind of useful for things that require callbacks that are one expression. Now, if your lambda requires more than one expression, then you're out of luck. You're going to have to write a function. But in the case where it is one expression, lambdas are excellent and allow for more clarity and readability. Again, this is a matter of taste. The functions work just fine. Now, you may be wondering what constitutes an expression in Python. Number one thing that constitutes an expression is that it returns. It has some type of return value. The other thing that constitutes an expression is that you can imagine it being on the right side of an assignment statement. So for example, if you were to go x is equal to 5, 5 is a valid thing to pass to lambda. So as an expression point of it. There are also ways of doing if then else in the lambda statements, which I'll cover next. But those are the two general rules when dealing with lambdas. Has to return a value, and if it could be on the right side of an assignment statement. There are also various other ways of writing expressions in Python. You can look up as many as you want, but as long as it is an expression, a singular expression, you can then use it on the right side of the colon in the lambda statement. Another thing that was included in Python 2.5, which often people think is another way of writing a condensed if-else, is a conditional expression. These conditional expressions are meant to be used with lambdas, which make the lambda a little bit more powerful. So for example, if we have a function that has a is a value, so 6, and then b is a value of 7, we can have a lambda called like so, takes no arguments, has a, if true, else b. That says that if it's true, then a, else it's b. We will assign this to a function here. We're going to call it func. Since it takes no arguments, we're going to go print the result of func, which should be in this case 6. Let's get rid of that extra noise there. Work that out. And then we have the 6 come out. That is a conditional expression. You can use these in line with other lambdas. There are a few other ones you can look up. I'll link those to the show notes. And that, for more or less, is how lambdas work in Python. They are very useful when trying to keep readability very low and for one-off, one expression functions in Python.